Calculate the parts per million of this right here. I don't know why it's stuck like that. Parts per million of this. You have almost a negative % chance of getting a part per million question, so we're not going to spend a ton of time on it. Like it's very, very unlikely that you get one of those. I don't remember. They're not considered hard. Parts per million is grams always, or mass. What do you mean carry the decimal? I do not move it over for ppm. That's fine, probably. It's really small. Why is it a yellow pen? That annoys me. That's hideous. All right, here we go. So parts per million, there's two ways to do it. Grams of solute over grams of solution. That's one way. Times 10 to the sixth. That should be a thing, not a negative. So I could take 0.05 over 2,000. Why 2,000? Because I have to multiply by 1,000 to convert. All right. And then I multiply that by 10 to the sixth. And I get what answer? 25. All right, Judy at 0.0025? Oh, okay. You're good there. Oh, okay. Then you'll get the same answer here. You don't need to do it this way. Whatever. This is how I always did it in my life. So sometimes I still do it that way. So I put 0.0005 over 2, and that's not going to work. What am I? Oh, I just went the wrong direction. I gotta pay attention here. I'm sorry. 3 the other way. So it is 550. Oh gosh, Tom. 50 over 2. Either one of them works. Just make sure you convert right, unlike I did for a second. Okay, part per million, not too hard. How would you change it to part per billion? Add 3 zeros or change that to a 9. Johnson. Okay, I know where you're going here. It should have been 0.005, or yeah. So it's negligible, that word we use. Because yeah, this should have been 2000.05. That is true. But yes.
So when you said add a 0, you can just find parts per million and add a 0 to the answer?
Add 3 zeros.
Okay, wait.
Because a billion has 3 more zeros.
Yeah. But wait, the answer could be 25,000 parts per billion.
Mm-hmm.
So you just add 3 zeros to the answer of part per million.
Yeah. All right, that's enough of that. Okay, mole fraction. Whoa, you don't like mole fraction? Hi, color mole.
Sorry to interrupt.
Yes.
Mrs. Sparks isn't here. If I have somebody who needs a Canvas password reset,
Oh, that's above my pay grade.
I couldn't
You can
remember.
go to the forgot password thing and submit it, and then someone somewhere sends them a new one, but that can take 2 days. Sorry. It's not us.
So I'd say 2 days is not his speed to begin with.
Okay, that's fine.
You don't have anybody like that in class, I hope.
Not in this one. Okay, here we go. And this is another thing, and maybe I'm doing you a disfavor, but I'm assuming you know how to do this by now. Mole fraction, or X, is moles of A over total moles of the solution. So in some application, this is actually a giant star here. We've never done this before. I mean, it's the same thing. You just got to read the question right. In some applications, which we will do here in a day, well, Monday, one needs the mole fraction of solvent, not the solute. 99, well, 100% of the time so far, we've been finding the mole fraction of the solute. But when we do colligative properties, which are in your future, we need it of the solvent. Make sure you find the quantity you need. Let me see if there's a question next. I didn't think so. So let's talk about what I mean by finding it for the solvent. If you have 20 grams of water, not water, sorry, of, we'll go with NaF since we still have that memorized from yesterday probably. If you have 20 grams of NF, sorry, NF, that was 2 summers ago, of NaF in, I'll just make it sort of easy here, 500 milliliters of water. And usually these are pretty simple. What's the mole fraction of water? So usually we would ask it for NaF, but we want it for water. Now we still have to find the moles of NaF because we need the total moles. Do you want me to walk it through with you at the start, or do you want to do it on your own for a minute?
I have one question.
Yes.
The 500 milliliters H2O, that includes the 20 grams of NaF, or is that before the NaF?
It's in it. So the answer would be before. So we take a thing and we add the powder first, and we add it up to the 500 milliliter mark. So yes, it's a little off, but 20 grams of that powder is not going to make any difference to my volume. So use 500 grams of water. And you will always do that unless the problem also includes density. Okay, I'm going to pause, probably. Here we go. I need, oh, okay, Tom, forgot about that, didn't you? I need the moles of A, which in this I'm calling water. So I take 500 grams of water and I divide it by 18 grams. Where'd that 18 come from? Tell your partner. That's the molar mass of water. So what do we end up with?
27.7.
All right. I'm just going to say 27.8. All in favor, say aye. Okay. That's moles of H2O. Okay. So that's my numerator. 27.8 over 27.8 plus, what do I need next?
The moles of NaF.
All right, so I take 20 and divide it by the molar mass, which is 42, is that right?
Yep.
And I get what?
0.47.
0.47?
Yeah, 4.
Okay, these are the total moles right here. This is the moles of A, and I put an equal sign. 0.98. All right. What would be the mole fraction of the solute then? 0.17, or in this case, 0.02 because of my rounding. The mole fractions of all of them will always add up to 1.
So it will be 0.02.
Yeah. Did that jive? Like why the other one you can figure out without doing a ton of math? The, all right, the fraction, all of them will always add up to 1. All right, so anyway, not hard. Find the moles it's asking for, divided by the total moles of the solution, and you're ready to roll.
Isn't this technically a percentage? Like it's the percentage of how much?
No, it's a ratio.
Oh, a
We
ratio.
think it's a percentage because we've always done this, but then we would always do one step that we never talked about.
That's what I want.
We would just say, oh, I got a 98%. But, and it is 98% if we were taking it as a percent. But we're going to use this number in math. So that's why we don't multiply it by 100.
Wait, so is this gonna be like literally kind of like a question on the test? It's not that hard.
Well, this piece is not. But, yeah, in order to solve colligative properties, we first find this number, which isn't hard, and then we use it. And that's not hard either, but the combination makes it tricky. Remember that big equation I showed you that I had to type out for a problem? The programming for just this, just to find the mole fraction, it was super tricky, super tricky, because you got to take your random variable and divide it by the molar mass and divide it by your random variable divided by its molar mass plus a different variable divided by its molar mass. So just right there, that was a ton of typing. And then there's other parts of the whole problem. So that's why I got really out of hand fast.
Do you like math?
It's not bad. Yeah, I like math. I don't love complicated math, but I like this stuff. I thought it was pretty cool. How do you type it in? You just say X, which will be your variable.
Or no, but I was just saying, like, how did you like come up with the like I wouldn't even know.
I did the problem and then I replaced.
The
So I
end
made up a number like this, like 20,
Yeah.
and I did all the math. And then I saw where 20 was important. I saw where this was important, and I converted them to variables, and then you type it in.
And then you also use the molar mass and have it.
Hmm. It's really complicated, but it's kind of fun. I know that's super nerdy. There you go. That's a better term. Very satisfying. What is unsatisfying is the one that I have that's like 70 characters long doesn't give me the right answer. And I can't figure out. It's because the denominator consists of like,
20 parentheses.
and it's super tricky for my mind to keep track of every single thing. I'm way triggered. It gets me close, but close doesn't matter. I don't know what I'm doing wrong. Okay, molarity. I know you guys know how that feels. Getting really close, but you're still super wrong. All right, molarity, capital M. Definitely need to remember a few things about molarity because we've gone over it big time. It is something we've really gone over. Molarity's unit is capital M. If it's in a problem, it'll just have a capital M. But it's more than that. It's really moles divided by liters. So if you don't remember what it really is, it makes the math a little bit tricky. So we're just going to dive in. We did a ton of this in chapter 4. All right, now this doesn't really matter to us. Like we would never do the math to calculate it, but very common on the AP test right here. I don't even know how to make you put this tiny thing in your notes important, but molarity is temperature dependent. The real truth is, who cares? But the AP test does. All right, so it'll have like a question. It'll be like, which one of these does not change with temperature? And then tons of people are like, oh, molarity is just moles per liter. That has nothing to do with temperature. But since volume is temperature related, this does matter, yada, yada, who cares? The answer, by the way, to that question would be molality, which is what's coming up next. But please, somewhere, some tiny place in your head, file away the fact that molarity is temperature dependent.
Why is it temperature dependent? Exactly.
Because volume of something changes depending on its temperature.
Oh, because it's like
It expands or contracts, but hardly at all. Like this is just dumb.
it's like such a small fraction.
Yep. Definitely. I don't think it's on mine. but I've seen it on the AP test probably every other year. Okay, we're going to do 3 problems today. These are the same 3 problems from the video. If you watch the first one, which we're up to 44% that have, that's better than normal. All right, we've done this stuff before, by the way. We're finding the concentration of the Mg plus ion if you have this much of it that you add to that much distilled water. Take about 2 minutes. See if we can do that, and I'll finish my shake.
So is this a percentage of this concentration? Oh wait, never mind. No, it's
Yeah, there's no percentage involved here. Anybody think the answer is A? Raise your hands. Okay, that's 4, 5, 6 maybe. B, C, D. Okay, so we have most here, 1 here. That can be up to whoever feels like saying it's that one person. This is the correct answer. All right. I'm sorry. All right. So capital M means what? Whoops, sorry, that should be, means moles over liters. So we need the moles and we need the liters. The liters, this might be where you made a mistake, is 0.6. Did you have that in the bottom? Okay, never mind them. Okay, now I need the moles. The moles is not 0.6. Now, they were nice here and didn't even give 1 as an option, so that would tell you that right now. You have 2 or 0.2 liters of 0.6 moles per liters. So it's, what's that? 0.12 moles. Now we did this in chapter 4 like 50 times. So hopefully that came back quick. You're like, oh yeah, to find moles, I take the volume in liters and multiply it by the molarity. So you have 0.12 over 0.6, and that is, I mean, that's just 2, but then move the decimal, whatever. That's A. Fair enough? Right here. Volume times molarity of the substance. I should point out something really important because I didn't. but you got to double check that you only get one ion per decomposition of this substance. Because if this was for chlorine, what would the answer be? It'd be 0.4. Because for every 1 MgCl2, I produce 1 Mg plus 2 Cl minus. So double check the subscripts as well. Everything in AP is tricky. Like I love it because it's hard and it pushes you. It makes you look at all sorts of things, but I also hate it because a lot of times you know exactly what you're doing, but you still screw up. What's that? Exactly. I don't even know what that means.
No, it's awful, and annotated bibliography, that's awful.
Okay, now you're bringing up nightmares from college.
Yeah, and
I command you to stop. Okay, the last two, this one was supposed to be easy. Oh, we haven't done 3 yet. This one's easy. This one's medium. And it's not that bad. And then this one's medium hard. It's not awful. But we're working our way forward. You can roll that whole cart over to you. Okay. Okay, so take 3 minutes and see if you can pull that off. Oh, come on, kids. All right, this thing means attached to. Just some substances absorb water from the environment and that makes them more stable. So they're called hydrates. So this is copper 2 sulfate hydrate technically, and it just means you have the copper sulfate, which to be more stable has 5 waters around it. They're actually a lot more common than you think, but they're not dissolved. They're just kind of stuck as a blob. So when you go to find its molar mass, which it gave you, copper 2 sulfate itself is like 157, but then you add 5 times 18. And
CuSO4 polar? Wouldn't that be a polar molecule?
it's not very polar.
Okay, I was just gonna say, it seems like they would be dissolved.
It dissolves. Sulfates typically dissolve except for when they're with certain whatever, I don't remember, like mercury and stuff like that. Okay, it even don't have a cow because it gave you the molar mass right here anyway. What? I would advise you to go back to our old friend. What's our old friend called? The picket fence. Now, if you would look right here, this thing right here is a proportion. I know it says mole -1, but it really means grams per mole, right? And then this capital M, that's a proportion. What does that mean?
oh, yeah.
Oh, wait, something per liter.
Moles over liter.
That was the I thought that's just copper sulfate. Oh.
That's this whole thing.
Okay.
Okay, now follow my logic here. The picket fence, we always start with the thing I give you that's not a proportion. So I'm going to automatically convert that to liters, 0.25 liters. Then what do I need to get rid of?
You need to get rid of the liters.
I have to bring liters down. Is there something up here that has liters in it? Yeah, capital M is 0.1 mole per 1 liter. So I got rid of liters. What am I trying to solve for?
You're trying to solve for grams.
Grams. So I have anything that relates a mole to a gram?
Yeah, the 250. Oh, so you multiply by 250 grams per 1 mole.
So what do you end up with here? Yeah, I was wrong. In my head when I did it, I divided. So I had 0.25 and 25. So I thought it'd be, anyway, doesn't matter. Here you go. So this is why Jed Smith loved these problems. Because he clicked in his head, like, why do work if I don't have to? That's like the motto of every kid, pretty much. He realized every single time I said, what mass? All you had to do was multiply every number you were given.
David said I love this.
Can we only do this on the test? No.
I need to give a big thank you to Jed Smith. May I just say he has trained me well at every occasion.
Yeah.
This is another time Jed Smith has come
So-
through for me.
Wait, so in this chapter, when you say what mass, that's all you have to do.
If I give you a molarity and the volume, I mean, it's tricky because we're in AP Chem. I ask for mass.
Don't just do that every time. Yeah,
No.
polarity, yeah.
But if you have a problem with molarity and volume and it asks for mass, multiply them. That's all you have to do. So
Okay, then we need to write a thank you letter to Jed Smith.
Okay, wait. But this is actually something I do not accept on the old fashioned way when you do something over something. What's the thing you were talking about when you try to
I
find
think I still follow Jed on Instagram.
solute over solution? Or mole
the mole fraction,
Yes.
this has nothing to do with mole fraction.
No, but when you find, wait, you're trying to find, oh, we're trying to find mass, though, not the molarity, confusing the molarity.
Yeah, all we need is how many grams. So listen, what this is literally saying is we want to make 250 milliliters of this solution. So and you should be able to, like, you may be asked to explain how you would make this. And you would say that you would add 6.25 grams of your solute. And then you would say, and then I would add water to the 250 mark. You would not say you add 250 and then add 6.25 grams. That would give you, oh, excuse me, that'd be a little bit wrong. Or the fancy way you'll read it in the AP test is it will say 6.25 grams of copper hydrate, and they would just tell you the formula, was added to enough water to make 250 milliliters of solution. That's how they write it.
And all that is just adding all the mass of it to get 250, right?
Right. What did this just show up? I don't know. Okay, here we go. This one's harder. I would still, if I were you, I would use our good old friend, Mr. Picket.
I'm gonna use our good old friend Jed.
I love Jed, but I know for a fact there's no way in the world Jed would get this problem right.
Okay, so I see we each other in the same boat.
But I do love Jed. I, in fact, texted him. He might be the last person I texted today.
You know if he's coming back for this spring?
He can't because he's still a college athlete. He was on red shirt then. Jed is the third person down, but technically the second person down because those are texts to me, not from me. Jed, in case anyone cares, he's competing today, and you can watch him live on the Weber State Instagram, the Weber State track and field. What equation? I can't give you a ton of time to work on this because the bell will ring. Oh, not even close. Not remotely. Thank you for asking, though.
I get so much hope from that.
You're welcome. Okay, I will give you 17 more seconds. Caitlin, you're so angry. I got this shake from Arbuckle.
I'm so close to Upton.
Yeah.
Married
Vol Buckle. We'll call her Val Buckle. Okay, here we go. Is it? All right, amigos, please follow along. These things are highlighted for a reason. Why? They are important, but they're also known as proportions. This thing right here, useless. The AP test will give you the temperature on over almost every problem, but it doesn't matter. Now, it gives you that because it sort of does, and some super anal retentive person will be like, well, what if it was at 250K? We don't care. We don't use it in the math. Here we go. What number did I give you that's not part of a proportion? 5 grams of what? What do I want to end up with? Liters.
So there's 7 zeros.
That says liters, by the way. Now you can put water, but that might confuse you, so I wouldn't. I would just put liters. All right, here we go. Now let's just use what we trained ourselves months ago to do. What has to be down here? All right, grams of AGBR, which is 188 grams of AGBR. And grams is always per what one thing? 1 mole of the same thing. Which means what must you have down here? Okay, hold on. I want mole AGBR. Now I know what you guys are trying to do and the math works, but just trust me for a second. This is talking about AG plus, correct? So is this AG plus right here? No, so follow me here. It's 1 mole of AGBR for every 1 mole of AG plus.
And then you go
Now,
down and
time out, time out, time out. This step is useless here, but it's not always 1-to-1. So please remember, you must go from what you were given to exactly what you want. Then I would have to balance that part out. And if it was for BR, I would put a 2. So this is 1 mole AG plus, not 1 mole, sorry. I'm an idiot. I tell my kids not to do that every time. This is mole AG plus, and I need liters. So, oh, hey, what's this thing right here? That's moles per liter, which can certainly be 1 liter has 7.1 times 10 to the negative 7 moles.
isn't that 71 million?
No, it's a negative.
Oh, I was
Now, yeah, we can flip a proportion whatever way we need.
is that 7?
Is it a really small number? No, it's a very large number.
Oh yeah, you're right.
What? If you know what you're doing, they will work for almost everything. 37457?
I knew what I was doing.
I'm just going to call it that.
I didn't know how to put it in my calculator.
All right. It is that big. Well, if you look at this molarity,
That's
this is
gigantic.
crazy, crazy small, not gigantic, small.
Small.
So if I have a little bit of grams, I'm going to have a really large volume because this is such a small number.
Oh yeah, because there's so much of that. So
Mhm.
moles make 5 grams.
Yep. Okay, my friends.